Ever found yourself pondering over how the instruments in an airplane operate? Well, aircraft instruments fall into four main categories: pressure instruments, using variations in air pressure; gyroscope instruments, leveraging the properties of gyroscopic inertia; magnetic instruments, utilizing the Earth's magnetic field; and finally, engine monitoring instruments. These instruments, including the airspeed indicator, altimeter, and vertical speed indicator, provide the pilot with vital information about the aircraft's speed, altitude, and rate of altitude change. As you can see, these instruments are crucial for safe and efficient flight operations. Dive into the world of pressure instruments. They use variations in air pressure and primarily inform the pilot about airspeed, altitude, and rate of altitude change. Let's begin with understanding static pressure. This is the pressure exerted evenly in all directions at any point in the atmosphere. It's the result of the weight of all the air molecules above that point, pushing downward. As the name suggests, static pressure doesn't involve relative movement of air. It's measured on the surface of an aircraft using a device called a static port. Next, let's talk about dynamic pressure. Imagine sticking your hand out of a moving car window. You'll feel an extra pressure due to the wind hitting your hand. That's dynamic pressure. It's felt by a body moving relative to the air. The strength of this pressure depends on two factors: the speed of the body relative to the air and the density of the air. The faster the car or the stronger the wind, the stronger the dynamic pressure. And it's also stronger in denser air, like at sea level, than in less dense air, like at high altitudes. So, the static and dynamic pressures are fundamental components of an aircraft's pressure instruments. Now let's delve deeper into the pitot-static system, a crucial part of pressure instruments. This ingenious system comprises two elements, the static port and the pitot tube. The static port measures the static pressure, which is the atmospheric pressure at the aircraft's current altitude, exerted equally in all directions. This pressure is a result of the weight of air molecules pressing down from above, and it doesn't involve any relative movement of the air. On the other hand, the pitot tube measures the dynamic pressure, also known as ram pressure. Imagine sticking your hand out of a moving car's window. The pressure you feel against your hand is the dynamic pressure. This pressure is felt by the body moving relative to the air, either the body moving through the air or the air moving around the body. So how does the pitot-static system determine airspeed? It simply calculates the difference between the dynamic pressure and the static pressure. This difference is known as the indicated airspeed. The system also measures altitude through the static port. As the aircraft ascends, the atmospheric pressure decreases, and this change is registered by the altimeter. Furthermore, the system can determine the rate of altitude change, or vertical speed, by measuring how fast the atmospheric pressure changes. The pitot-static system, hence, plays a pivotal role in providing speed, altitude, and rate of climb or descent information to the pilot. So, what have we learned today? We've delved into the importance of aircraft instruments, understanding their crucial role in our flight experience. We've explored pressure instruments, which utilize air pressure variations to provide vital information to the pilot. Furthermore, we uncovered the workings of the pitot-static system, a remarkable technology that measures static and dynamic air pressure. Next time you board a flight, remember, an array of sophisticated instruments is working seamlessly to ensure your safe journey.